I also wanted to give a quick note about our vocabulary here. So this is stuff we're gonna keep on talking about for the rest of the term, so just to avoid confusion, I wanna be really clear about what I mean by all of these terms right now. So to begin with, we're gonna have, a random variable y, and the data that comes out of y when we sample it are the yi's. So here's, it's 4, 2, 1, those are the yi's, and we're gonna refer to y as our dependent variable. That it's the outcome. It's what we're trying to predict. What the data generating process of that we're trying to describe. So that's our dependent variable. And we'll also have, another random variable x, and the sample that we get from x is our xi's, and I'll usually refer to xi as the explanatory variable, but you'll also see it as the independent variable. I like explanatory. Explanatory variable. And then we have these two parameters, beta naught and beta 1, and that's of course the intercept and the slope. And then when we put hats on those parameters, that just refers to the estimate of the intercept and the estimate of the slope. So beta naught hat and beta 1 hat is the estimate of the intercept and the estimate of the slope. And then, let's see, what else do we have? So another part of the true model is the reason why all of the data points are not going to usually fall directly on, exactly one line is that there's a disturbance term, what I'll call U. And that's always going to be unobserved to us. We don't see it in the data. There's some unobserved reason that all of the data points don't fall in a line, so I'll say unobservable term or disturbance. Unobservable variable. So, y, x, beta naught, beta 1, u, these all determine the what we call the true model here. And then we also have our estimated model. Our estimated model is y is, I'll put an I, and put i's on these. Yi is beta naught hat plus beta 1 hat plus, and instead of a u, I'm going to say ei here. Should also have an I. Just to keep these really, really different. And this is a big focus in the class, the difference between u and e. E is, I guess, our estimate of u, but e is something, so ei, something we call our residuals. And our residuals are manufactured from the OLS process. When we use OLS to fit this line of best fit, the residuals are I want a thinner line here. The residuals are manufactured because, whoa, that wasn't even linear. Okay. So the residuals they'll be the vertical distances here. From here to here. Here to here. And here to here. They're so it depends. What EI is depends very heavily on how we pick this line of best fit. If we pick the line of best fit out here, then our residuals would be much larger. That's not a line of best fit. Line of best fit is defined by minimizing those residuals. And then, importantly, the residuals are the vertical distances, because we don't care about, predicting x. We want to predict our outcome variable. which is y. So we care about, you know, let's say for this x, we want this data point on the line of best